Guys, I thought I'd go over an ADC today. Now, an ADC allows you to get real-world analog inputs and convert it into digital outputs that a computer can read. At the heart of an ADC is the comparator. Now, how the comparator works is if the plus voltage is higher than the minus voltage, it'll output 5 volts. Otherwise, if the minus voltage is higher than the plus voltage, it'll output 0 volts. So this can be used to convert unknown voltages into a voltage that a computer can read. So if we assume that our input voltage is, let's say, 5 volts, we can put an increasing voltage on the plus pin until it goes to 5 volts. And then once it goes to 5 volts, that signal will be sent to the computer, and the computer will know what voltage it is. So if we assume that this is at, let's say, 3 volts, we can put this on 2.99 volts, 3 volts, and then at 3.01, since 3.01 is bigger than 3, this trigger will go high, and then the computer will know that the voltage is roughly 3 volts. Now the trouble with this is that this requires it requires you to be able to put in a wide variety of voltages on this plus pin. So like, let's say if this was 1.25 volts, ideally you'd have the plus pin be able to go up to a very slow step up until you reach like 1.250001. That way you know your trigger will go off, and you know that your unknown voltage here is 1.25 volts. Now to get a wide variety of voltages on this plus pin, what I built is what's called a R-2R ladder. Now essentially what this thing does is it allows your computer to input logic voltages and then output analog voltages. So these are the inputs right here. I called them bit 1, bit 2, bit 3, bit 4, bit 5, bit 6. So all these voltages are 5 volts since I'm using the Arduino, and then its logic highs are 5 volts. Now how this works is it essentially follows this formula right here. So depending on what bit it is, it adds a certain amount of voltage. So if bit 1 is on and it's the only one on, it adds 1 over 2 to the power of the bit number. So 2 to the power 1, which is just 1/2, times the logic value, or the logic voltage. So since we're using the Arduino, it's always going to be multiplied by 5. So we'd have 1/2 times 5, or 2.5 volts, if just bit 1 is on. Now this is a summation voltage, so this one would add half of 5 volts, this one is going to add 1/4 of 5 volts, this one's going to add 1/8 of 5 volts, and so on. So this thing has essentially the range of 0 to 5 volts. Now, if you remember earlier, we want this to have a wide variety of voltages, but this can only go from 0 to 5 volts. So it's really good if we want to if we're only going to have analog inputs that range from 0 to 5 volts. But if we have a larger range, this is no good. That's why we have an amplifier right here that amplifies our 0 to 5 volts by a factor of 2.5. So if we have 1 volt on here, it'll multiply it by 2.5, and we'll get 2.5 volts here. So we get a wider range of voltages, but the trade-off is that we get less resolution. So this is essentially how the thing works. It starts off at a low voltage at 0 volts, and it keeps on stepping it up, the voltage, until it reaches our unknown voltage. Once the input voltage has exceeded or gone over it, it stops, and then you know that the voltage is somewhere around the voltage that it stopped. So in this example, it would stop at 3.5 volts, even though the real voltage is three and a quarter volts. So because of this, the red voltage will always be a little bit higher than the actual voltage. And the better your resolution, or the smaller your steps are, the closer to the actual value that you'll reach. So this is the actual circuit setup right here. This is the ladder right here, and then we have the amplifier chip, which is this big one right there, and then the comparator is this small chip over here. So, and our mystery voltage, I'm just using the potentiometer, which allows me to easily get a large range of voltages from 0 to 15 volts. So right now I have the multimeter hooked up on it, and it's at roughly 2.22 volts. Now if we go to the computer, it's reading 2.34 volts. So as we expected, the voltage is going to be slightly higher than the actual voltage, but it's pretty close. And the bigger your ladder, the smaller your steps will be, and therefore the more accurate the number will be. But I kind of ran out of resistors, so this is about as accurate as we're going to get. So if I move the potentiometer right here, which is essentially our input mystery voltage that we don't know, if I move it this way, the voltage will increase. So right now it's at 5.53 volts. And if we look at our reading, it has increased as well. And so it's kind of jumping around 5.47 and 5.66. So it definitely has some error to it, but it's pretty neat to actually see that it follows the voltage as you move it. So like right now I'm moving the potentiometer. Now if I go out of the range of the comparator, I wrote software where basically it just tells you that it went over, you know, the voltage that it can compare. So usually it's around within 0.2 volts of error, but sometimes it can be a little less, sometimes it can be a little more. So yeah, that's about it. Thanks for watching.